Hi, I'm Kathy Kellenberger with Pragmatic Works, and window functions is a tool that we use. So for example, in my area, this is, oops, get the slide to advance. In my area, this is what it looked like as I looked out the window on Sunday. And being human, we have tools at our disposal to take care of problems like this. For example, we have brooms, we have shovels, we have snow blowers, we have plows. So this is how we dealt with it at our house. We have this nice tool that we used to clear out the driveway, even though we hadn't planned to leave the house for a couple days. And you know, whenever my husband got this shiny new tractor, he couldn't just get on it and know everything about it. He had to spend some time understanding the best way to use it, to see if some older implements that he had would fit on there. That rusty yellow thing on the back actually hooked right up to his new tractor. But he had to spend some time understanding how to best use this tool. He couldn't just get on there and just go. Well, he probably did. He's a guy. He probably didn't look at the manual that close at first, but he had to learn how to use it most effectively. T-SQL is no different, and especially the window functions. We've been using window functions for a few years, at least many of us have, and if you're not familiar with what the window functions are, I have another webinar coming up in a month that talks just from the beginning what they are, and I've also done that session before, so there is a recording from a few months ago when I gave it as well. So we've been using these window functions, but we may not have had enough information to use them effectively. So what I'm going to talk about today is just give a very brief overview of what they are. They're nothing to do with the window operating system, and then by the end of this session, you are going to know the secret of how to tune your queries that include window functions. And if you call now, before this webinar is over, for the same price, I will give you not one, but 2 secrets. So stay tuned to learn more. So what are window functions? As I mentioned, they are nothing to do with the Windows operating system. It's standard functionality. This is part of the ANSI standard that was added to T-SQL in 2005, and then some more added in 2012. You'll always see an over clause when the window functions are used. That's not a 100% guarantee that you're looking at a window function. But if you have a window function, you always have an over clause. And that over clause defines the actual rows or set of rows that the function operates on. Okay, so we can have a window that's the entire result set, or we can break that down into partitions, and then starting with 2012 we can get even more granular with framing. And again, if this doesn't sound familiar to you, stay tuned today, but then go ahead and review the previous video that I did that did a real deep dive into what these are. They're always found in the select and order by clauses. That's the only place you can use them. And the benefit, probably, I don't know what the biggest benefit is, but the really cool benefit to me is that they make queries easier to write. Some complex problems to solve, using window functions make those queries easier to write, less code, easier to read, easier to maintain, but you also get better performance. Well, most of the time. There's one situation, there's one particular type of window function that you don't get better performance. The older ways are actually better performing, and even if you use the components or the functions that do give you better performance, if you don't know the way to get performance, if you don't know what's going on under the covers or how to get that better performance, you won't. You might get the same or worse. So that's what we're going to talk about today. In 2005, we were given the ranking functions, row number, rank, dense rank, and entile, and many of you are using row number and may not even know that it's a window function. I didn't even know, really had been familiar with this term until a couple of years ago, and I've been using row numbers since it came out, and I love it. A lot of times if I don't know how to solve a problem, I just add row number to it and just start looking for a pattern. In 2005, we also received window aggregates, which is a way to add summing information without an aggregate query. So in other words, we can aggregate over this little window of rows and add that to our detailed data. In 2012 is the next time that we had any updates to this, and in 2012 we received framing, which allows us to even more granularly define our window, and we were given the order by clause for Windows aggregates. So this allows us to get a running total or accumulation of numbers. We were also given, I can't remember if it's 8 or 10 analytic functions. There's no plans that I have heard of to do anything with these in 2014, which is really sad. No enhancements, no new features. We're stuck at the same point. So hopefully in the future we will have other functionality added to this, because there is more functionality that could be added, and also more things to maybe enhance it or get even better performance. So first, let's think about execution plans. What are we looking for in the execution plans? These are two new operators that you'll see, and there's nothing bad about these operators. Don't freak out when you see them. This tells us that the window functions are doing their jobs. The first one is the sequence project operator, and that operator just says that this calculation is being done. Okay, and also a segment operator. A segment operator you'll see whenever there's partitioning. So in my over clause, if I have partition by, then we'll see this segment operator. And basically it's doing kind of what it says. It's segmenting this data into the partition so this calculation can be made. Two other things you'll see are table spool and window spool. So table spool is a work table. Actually, both of these are work tables, and it's used to help do this calculation. Table spool is always created in TempDB, and whenever you see a table spool, you'll know that there's not the absolute best performance. But there may not be anything you can do about that except maybe use another technique. We'll talk about that later when we get to the demos. Starting in 2012, you'll also see the window spool. The window spool may be created in TempDB, but it also could be created in memory. And when it's created in memory, it uses hardly any resources whatsoever, and it performs amazingly, almost magic. So you'll see both of these, and when you look at the execution plan and you look at the window spool, you can't tell by looking at it whether this window spool was created in TempDB or in memory. You have to look at statistics.io. So really, when you're tuning these queries, you can't just use one tool. You'll have to use two tools that you have at your disposal, or at least two tools. You'll have to look at execution plans, you'll have to look at statistics.io, both of those to see the whole picture. Another thing that you'll see, and this is nothing new, but this is something that you really want to watch out for, and that's a sort. Notice when I copied this out of whatever execution plan that I ran, see that cost is 80%, and that's going to be the most expensive operation in your query. So the first thing about tuning these queries is to get rid of that sort, and luckily it's not that difficult to do. So let's talk about indexes. That's the way we're going to get rid of the sort. So before I explain the index to you, I want you to think about your query. Does this query that I'm writing, is it important? Is it extremely important that I get the absolute best performance that I can out of this query? If it's a one-off query, probably not. If it's against a smallish table, Probably not. If it's a query that runs 1,000 times a minute in your environment, yes, we need it to be the best performing query. If it's a report that's taking, an hour to run, well, maybe adding this index is going to help us. So we can't add an index for every query that exists, because then we end up with other problems. That's another session, but we have to just pick and choose which queries that we want to optimize. So if we decide that we do want to optimize this query, this is the secret sauce right here. This is the index that you need. This is the POC index. And POC stands for P for partition, O for order by, and C for covering. So inside our over clause, we can have a partition option, we can have an order by option. So that's where those come in. And we probably are going to have some other columns in our query. So that's what we need. And if this table that we're working with is part of a join, or if there's any filtering involved, we need to include those columns as well, so put those up front. And also the order that we add these columns is very, very important. So for my non-clustered index, for my key, I would have the filtered columns plus the partition column plus the order by column. Then I could add any other columns that I needed as covering columns. Okay. If there is a clustered index that will work for this, then I don't have to worry about the covering columns, because they'll just be part of the clustered index anyway. So let's take a look at some examples. So I'm working with AdventureWorks 2012 here, and about half of the examples will work in earlier versions, about half will only work in 2012. Remember that there was functionality added at 2012. So this is well, what I've got here, I've got 4 queries that represent 4 types of window functions. For example, here's row numbers. This is going to represent our ranking functions that were available with 2005. I have a window aggregate. So what this particular query does, if you haven't seen this before, is allows me to display detailed data. So I've got all this detailed data, and I also have a sum that is partitioned or broken down by customers. So what this query does is allows me to have a subtotal for each of my customers. And notice that even though I have sum in my select list here, I don't have a group by. So that's what window aggregates do. Starting with 2012, we could add an order by clause to our window aggregate. So this is a complete different beast here. So what we have here is a running total. So this is a running total as opposed to a subtotal once I add that order by. And then finally, we received a series of analytic functions. These are, there's lag and lead, and there's some percentile types, a bunch of different ones. This is just one example, lag. And what lag does is allows me to take a peek at an earlier row. And the really cool thing about these is that they perform just amazingly well. So anyway, let's take a look at these 4 functions, and we don't have any special index on any of these. Let's see, I want to look at my execution plan. So I'm not going to really care so much about the results of any of these queries. What I'm really going to focus on in this session is the performance information. So in this case, we've got, let's see if I have zoom it on. I do, yay. We have 689 logical reads, which is not many. This, of course, this is a really small table. in the grand scheme of things, this is not a very big table. So let's take a look at the execution plan and see what we can learn from that. If I take a look there, I see that sequence project and I see that segment. So that tells me that really this is just part of window functions. It's not anything to worry about, and it's what I expect to see. But here's the culprit, this 80% sort. So how can we get rid of that? Okay. Well, let me just, before I get id of it, let's take a look at these other functions to see what we can learn here. So this particular function, it makes this query easy to write. However, there's some problems with the performance. It doesn't really perform as well as other methods to do the same thing. Notice that we have a work table, and hopefully you remember me talking about a work table when I explained the changes in execution plans a few minutes ago. I have that 689 logical reads, but I also have this terribly big number of logical reads on that work table. If I take a look at the execution plan, I can see that I have the table spool that tells me that this work table is created in TempDB, and basically what's going on is the table gets filled a segment at a time. So if I have a partition by, I will add just the rows needed for each calculation over and over and over. And again, I have, where is it? I know it's in here somewhere, but I should have the sort. There's the sort. I have also an expensive sort. Okay, so just keep all that in mind. Here's where I've added the order by. This is that newer functionality with 2012. When I execute this, I'm going to see also I've got this problem with these logical reads here. And if I take a look at the execution plan, again, I've got the expensive sort. So if I can get rid of that sort, it's going to solve part of my problem. Luckily, there's some other things that we can do with this query to improve it that we'll learn about later in the session. Finally, let's take a look at this analytic function. So what this is going to do, and I'll go ahead and look at the results on this one in case you're not familiar with it. What this is going to do is give me a peek at an earlier row and allow me to grab a piece of information from a previous row. And so, for example, if I'm on this customer, this is the first order. There's no order to look back at. If I'm on this customer, I can look back and see this row. It's a really, really cool function, one of my favorites. If I take a look, I see something really nice here. I'm seeing that there are 0 physical reads and 0 scans, 0 logical reads on my work table. I still have the 689 logical reads. If I take a look at the execution plan, I see that that sort is my culprit again. 77%. So if I can just add an index that will solve these problems, and in this case, all of these queries that I wrote just happen to be using the same partition by where the order by is actually supported. I've got the same one. In this case, I mean, this is not a real-world example, but there's one query that I can, or one index that I can add that's going to improve the performance of all of these queries. So here it is. I'm going to add my P for partition, O for order by, and then here's my covering columns. So let me go ahead and create that. And then let's take a look and see if we have improved things. So these are the same queries that I ran a few minutes ago. And if I take a look at statistics.io, I see that now I have just 119 logical reads, where before I had 689. So that's really good. So you may be wondering, well, why is that? Why did adding this index decrease those logical reads by such a large amount? It's because this particular index has everything in it that I need to solve this query. It's basically a covering index. Since the index has exactly what I need, it's much smaller than the original table. Okay, so I'm reading the entire index in, but it is a much smaller number of pages than the clustered index would be. If I take a look at the execution plan, I'll also see that my sort is gone. So I got rid of that, and I'm scanning that non-clustered index. So that query is tuned. That's really some really good work there. So this one is that aggregate function. Previously we had 139,000 logical reads for the work table, 689, plus we had the expensive sort. So unfortunately, when I run this, I'm still going to get the same logical reads for my work table. However, the logical reads for the index, for the actual gathering the data initially, is that 119. If I look at the execution plan, my sort is now gone. So I was able to improve this somewhat, but there's really nothing else I can do with this query besides using a different technique. And later in the session, I'll explain to you the other techniques that you can use. Here's my order by, this is the running total definition. So previously I had 188,000 logical reads in my sort. So you may think, this is going to solve everything. Well, unfortunately, at this point, we still have that large number of logical reads with our work table. This is telling me that my work table is created in TempDB, not in memory. I do have a decrease in the logical reads of just scanning that index instead of the table, and my sort is gone. So you'll learn the second secret of tuning these queries later in this session, and we'll take care of this one. Finally, this analytic function previously had 689 logical reads plus the sort. By adding that index, we end up with 119 logical reads again, and our sort is gone. So that query is tuned really well. So of these four queries, the row number is in good shape, the analytic function's in good shape. We still have some work to do on this running total query, and on this guy, if we really need better performance here, we just need to use a different technique, and that is really sad and unfortunate, but that's just the way it is. So other things to keep in mind, for example, if you decide to do descending order instead of the regular order, if I run this, my sort comes back. So I've got that sort back again. And what I could do is create another index that sorts that sales order ID descending. And if I do that, then my sort will go away. But again, we just can't add indexes willy-nilly just for every single query. So you have to pick and choose when it's going to be advantageous. There's some other things about using descending. I was not really able to reproduce it on my laptop, which basically has to do with parallelism. If you certain queries will have parallelism that you generally want as long as everything's in good shape, statistics are in good shape, it's a good query. But when you go reverse, then the parallelism goes away. And I really wasn't able to reproduce that on my workstation or on my laptop, so I'm going to just skip that. But I can provide some information in the blog later if anyone is interested. Here's another kind of crazy thing. So as a DBA, I might look back at this index that we created and say, hey, sales order ID is actually the cluster key. So since it's the cluster key, I automatically get that for free in my non-clustered index. So why am I writing this, creating this index where I'm adding sales order ID at the key when I just by default I get it in the included columns? You know, you don't even see it, you just get it. Well, here is an example using a bigger table, and this is a big table. This is from Atom Mechanics Big Adventure Scripts, and I have that in the I have the link to create this table in the slides. But anyway, here's a particular table called Big Transaction History, and it has a clustered index on transaction ID, and it has a non-clustered index on product ID, which is my partitioning column, and transaction date, and it includes quantity and actual cost. So theoretically, I could run a query like this and say, hey, my transaction ID is already part of my non-clustered index, so this should work fine, right? So I'm not going to run this whole query because it's going to take several minutes to run, or maybe even time out, but I'm going to display the estimated execution plan. And you'll see that I get this big sort, even though the index, the non-clustered index was used, I still have this big sort. And so what I have found that even though this column is included in the index, it actually has to be part of the key. It really has to be there. So if I change my query and instead use transaction date here, which will give me similar results, not exactly the same results, but similar, because this is not unique, then I will lose my sort. But it looks like I also lost my parallelism as well. So that's another thing to keep in mind. Just because this column is part of the cluster key and therefore part of the non-clustered index, it still has to be the second item in that non-cluster key in order to get rid of that sort. So let's go back to the slides and see what else we can learn. Hopefully that all made sense, and it's really, that index is really not difficult, but boy, trying to find that information out was very hard for me. And at the end I'll show you a resource that's really the Bible as far as window functions. So the next thing that can help us with tuning is called framing. And framing allows us to find a more granular set of rows in our window. By default, where framing is supported, and it's not supported in everything, the default is range between unbounded preceding and current row. So one of the places that framing is supported is when I'm doing that running total. So when I do the running total, by default, I'm looking at all the previous rows. So if I'm on row 10, I'm looking at row 1, which is the unbounded preceding, up to the current row, row 10. So I'm going to do a calculation on row 1 through 10. If I'm on row 100, I'm going to do a calculation on row 1 to 100. Range is not fully supported in this version of SQL Server. There's other things that range can do. One really sad thing is that it has worse performance than rows. So rows between unbounded preceding and current row will, I'm going to say, probably give you the same results. It may give you more likely give you the results you're looking for, and it's going to perform much better. The reason that it performs better is that rows is going to go ahead and create that work table in memory, where range will create the work table in tempdb. So that's the difference. There's also another optimization that SQL Server knows when it sees unbounded preceding and current row, it knows to start accumulating. So instead of filling up that work table with all the rows every time for every window, for every row, instead of doing that over and over and over, it says, oh, let me just keep accumulating. I'll look at the total I had from the last time and I'll just add this value to it. So it actually works more efficient in that way too. Remember a couple seconds ago I said that range and rows will give you probably the same results. There are situations where you will get slightly different results, and that's if that order by column is not unique. So be very careful with that, and I'll show you an example of where that comes into play. So let's take a look at some examples. Okay, so here's a query that we ran in the last demo where I'm getting a running total. And I'm not specifying the frame here. Since I'm not specifying the frame, that is actually identical to running this query where I'm saying range between unbounded preceding and current row. That's understood. That's the default. So if I go ahead, I'm just going to run both of these. And when I do, I'm going to get identical information in my statistics.io and identical execution plans. So if I would change, let's see, this is sales order ID is unique, so I would, if by changing to rows, I am going to get identical results, and that's just because sales order ID is unique. But look what happens when I run this query. Now I'm getting 0 logical reads. So that's the trick to performance tuning these other queries where framing comes into play. Unless there is a specific reason to use range, use rows instead. So I want to show you the difference between rows and range. I'm going to create this one little non-cluster index that's going to help us with these queries. So what I've done is I looked for a customer who had multiple orders on the same day. So if I change this query and I use order date instead of order ID, I'm going to get different results. So if I run this one, I'm going to get what I expect. I'm going to get an exact running total. So let's just take a look at these results. You can see this is the same customer, and you can see that this value just keeps getting larger and larger. If I use range instead, or if I just left this out because it's the default, you'll see the difference. You'll see what happens. Anytime that the order dates are the same, I'm going to get the same value in the running total. So this is not wrong per se. Basically what's happening is that when I'm on this row, it is logically the same as this row as far as range is concerned. When I'm on this row, it's logically the same as this row. And here's another example. This is one of the analytic functions that uses framing. First value uses framing. And basically what this does is let me go and grab any column that's in my first row. Okay? But then I can define what I want this frame to be. In this case, it's going to be the range instead of rows, because I am using the default. So when I take a look at that, again, I've got this crazy amount of logical reads. But if I switch, write the same query except add in my, explicitly say rows between unbounded preceding and current row, then what happens is that my logical reads are 0. So unless there's a reason, a very specific reason that you must use range anytime that framing is supported, be sure to explicitly state rows. That's what's really, really important. Okay, let's go back and take a look at some comparisons. And I feel like I've gone through that really, really quickly, but you can always go back and watch the recording again and put it on slow speed to slow me down a bit. So what I did here is I took some tables. I took Atom Mechanics big transaction history table, and then I just created 3 other tables that were like that one, and with not so many rows. So basically I took 50%, 25%, and 12.5% of that table. And on those particular tables, I also added the same primary key, cluster key, and I also added the same non-clustered index. And then I wanted to do some comparisons between the different types of, or the different methods of solving the same problem. So in my subtotal, remember this is the one that I really was not getting the best results. It doesn't support framing. That temp table, or that work table always ends up in tempdb, so it's not always the best. So my times here for running this query were not too bad considering how big the tables are. So even with 15 million rows, it took 39 seconds, which is not horrible unless it's really important that this query run as fast as it can. Then that's a bad thing. If I use a common table expression, I was able to get much better results, and also by using a correlated subquery, I was also able to get identical results to the common table expression. So when I get done showing these comparisons, I'll go back to the demo and I'll show you exactly how to write these other queries. And I'm sure there's some other methods out there, but these are the 2 that I like to use. I'm really partial to the common table expression, actually, and in this case it was identical to the correlated subquery. The other thing that's really cool about window aggregates is that once I define this window, I could have other calculations performed on the same window, and it really won't make any difference as far as performance is concerned. So here's my results whenever I added not only a sum but a min, and it was on the same window. The over clause was identical. So on the window aggregate, my performance stayed exactly the same, and on my common table expression, it stayed exactly the same. I did see an increase in correlated subquery, and that's because every time I add another calculation, I have to scan the table another time. One thing I need to tell you about how I came up with these results is I went ahead and I turned off the results to grid. So basically what happened was I discarded all the results as I ran these, because what I found was it was taking 2 minutes, almost 3 minutes to run each one of these queries because of the way that Management Studio processes the rows as they come back, this row by row. So I wanted to take a look at just how SQL Server handled the query, not how Management Studio did. So in the demo code, if you decide to download that from my blog later in the week, I've got an explanation of what's going on, and then I also have some other numbers of how it ran when I did have the results going to the grid. And even then, it was not a lot of difference. There was so much time taken up by displaying the data in the grid that there wasn't a lot of difference between the 3 methods. So that's 2 calculations. The other thing I wanted to compare was running the running total. And the window aggregates, and this is window aggregate with the order by and framing, I was able to get amazing results. Even with 15 million rows, I was able to get the query to actually, I didn't really return the results to myself, but to get the query to process in 18 seconds. If I use the join method, and again, I'll show you these different methods as I get to the demo in a couple seconds, the join method wasn't so bad when I had a smaller number of rows, but you can see it just incremented, it just got really much worse very quickly, even up to 39 minutes. The correlated subquery method took, again, it started off not bad and just very quickly got worse. So if you are doing anything with really anything that is supported by this framing, be sure to use it, and you'll get much better results compared to older methods. Okay, so let's go ahead and get back to the demo, and we'll take a look at how to write these other queries. So these queries here are not the ones that I used to get that data. I used the big transaction history. Actually, I made like a medium and a small and a tiny transaction history, and the code to create those is actually in this demo that I will upload for you. But I just wanted to show you something that we had been mostly working with throughout this session, so you'd be familiar with it. So we've seen this query before. This is the one that we cannot get rid of that work table in TempTV. That's really the problem with it. If I do this as a common table expression, this is how I would do it. I would go ahead and create a query that would run independently, where I'm using a group by to get the subtotal for each customer. Then in my external query, I go ahead and join on that. So I'm going to get, let me go ahead and run these two together, and I am going to get much better performance. Actually, I scanned the table twice, or scanned the index twice to get this to run. And if I hadn't had that an index that was beneficial, I would have done a table scan instead. But you can see the difference. Here's the bottom one is the common table expression, 238 logical reads, and the top two values are from the window aggregate. So there really is an advantage to using another method when you're doing window aggregate, unless, you know, performance for that particular query isn't crucial. Then the window aggregate way to write it is so much easier. This is so much less code, so much easier to read than this. Here's another way to do it, a correlated subquery method. So what I have here is in my select list, I have this subquery that returns a scalar value. It returns a total due, and I'm basically, I'm not really doing a join, kind of like a join. I'm using the where clause to join on the outer query. So there's no way that I can actually run this query by itself, okay? And I don't really have to use a group by here, because this query is going to run really once every time for the outer query. I still get better performance than I do with the window aggregate method. So you just have to use some caution here whenever you need to do this. And this is a really common thing that you might have to do. You'll just have to use a little bit of caution on what method that you use. This is just the one crazy exception. Window functions, you know, are fantastic. This is just the one exception where you need to use some caution and that you may not get as good of results. Here's an example where I'm using two calculations, and notice as long as I have the same over clause, SQL Server will just use that to its advantage to perform this calculation. If I'm using a common table expression, it's the same kind of idea. I don't have to have two common table expressions here, one for sum and one for min. I can combine them in the same time. So both of these we're not going to see any increase in the amount of time, or I/O, to run these two. If I use the correlated subquery method, though, notice that I have to scan the table multiple times to do this. So probably behind the scenes, SQL turns this into some kind of a join. But regardless, this one, even though we've got the same exact query except for the function here, we are actually going to see decreasing performance as we add more of these. Okay, so this may not be a good method if you have multiple values to calculate. Okay, so the last thing in the demo, I'm not really going to run all of these. Let's see. Oh, wait a minute. Correlated. Okay, yeah, here we go. The running total comparison. Forgot about that. Okay, so the running total comparison, this is what you should use. Don't forget to add the framing clause. Don't forget that, because you will definitely see an improvement in performance by using it. If you don't use it, it's range, then we know what happens there. Here's the correlated subquery method. So it's very similar to what we just did, but then I also have to make sure that I only look at the previous values. So that's how that works. And the join method, let's see, I'm joining. Here I have to have a group by, but I'm doing a self-join on the table, and again I'm doing this inequality here to make sure I just get the correct values. Another interesting thing I thought about as I was putting this together is if I had used sales order date here instead of sales order ID, I would have a similar problem with the calculation. Just like I showed you a few slides back between rows and range, I would get the same thing. So if I used a non-unique value here, I would get some duplicates in my calculation as well, in that running total. So these, as you can see from the comparison slides that I showed you, these are going to deteriorate very quickly. These are really bad news. And if you ever do a search on this method, on either of these methods, you'll hear the term triangular join. So it's basically like half of a Cartesian product. Okay, finally, I'm not going to run these, but I wanted to just provide with you the queries that I used for gathering the information for the slides, and I also provided some information. So the information here is how much it took to run with the results going to the grid. I also have some other information, the statistics time, and also the statistics I/O information. So what I did is I had a medium, small, and a tiny transaction history table. I don't have all of those queries here, but you could go ahead and reproduce the same thing if you wanted to try this out. So I have all the methods. Basically, I just have all the methods just with the medium transaction history table. If you want to reproduce what I did, there's code at the beginning of the script that shows you how to create all the tables that I used. So that is, yeah, there's quite a bit there. I'm not going to go through all that. So let's go back to the slides. Looks like we might have time for some questions in a couple minutes. So what we covered today was that the POC index can help all window functions. Okay, that can be beneficial for all window functions. Whether or not you choose to implement the index for a particular query is going to depend on how much of a benefit it will be to your application or report. Just don't go and add it to everything just because it's a window function. If it's something that supports framing, make sure that you use rows instead of range. Range is the default. If you use, unless there is a business reason for using range, because sometimes you will get slightly different results. If you would like to use the window aggregate function, by all means use it. I love it. I use it a lot. Use it with caution if performance is critical. But those are really the main points that you should have gotten from today. That's the secret sauce. That's the secret information that's hard to come by. So finally, I have some resources for you. I have the link to Atom Mechanics' Big Adventure script that I used to create the big tables that I worked with. The book shown here is really the Bible as far as T-SQL window functions. You know, buy that book. My copy of the book is getting so dog-eared, and I'm thinking about getting a Kindle version of it as well, so I always have it with me. But I'm constantly learning something new. The window functions are like an onion, and I just keep pulling back layers and learning more all the time. I have a window function webinar that's really an introduction to these functions that really dives pretty deep into them as well. So there's a link to that. Plus, I will also be giving that webinar again next month, and it's also part of the past summit slides, past summit recordings if you went to summit and have access to those recordings. I have a blog where I have many posts about window functions. If you are on Twitter, I can occasionally be found on Twitter under the name Aunt Kathy. I am not on Twitter that often, and there's my email address. So what I would like for you to do, what all of you to do is, if you aren't using window functions, start thinking about how you can use them. And I know I really didn't cover in this session, you know, why or how so much, but start using them. If you have been using them, now it's the time to start thinking about the performance, start thinking about the impact that they make, and now you have the tools to actually get the best performance out of them.